In this class, let us study about the properties of the angle subtended by the arc of any circle. We will see 3 different cases and we will see why they are different. First, let us see what is the arc of a circle. Consider any 2 points on the circumference. Then the piece of the circle which lies between these 2 points is called an arc. Or in other words, what is arc? It is just a piece of the circumference. Drawn separately, it will look like this. But there is a problem here. What is the problem? Suppose your mother cuts a piece of a cake and gives it to you. There will be something left, right? There will be a bigger piece left. Now, that will also be the piece of the cake. Or in other words, if this is the piece of the circumference, if this is an arc, this will also be an arc. But you see the difference? This one looks smaller and this one looks bigger. So this we call the minor arc PQ and denote it like this, and this one we call the major arc PQ. And another way for denoting the major arc is randomly take any point on the circumference, not inside the circle, on the circumference. Do not take O, because usually we use O to denote the center of a circle. Take any other alphabet, suppose A. Take randomly any point and instead of writing it like this, write it as PAQ. That means we are talking about a bigger piece of the circumference. This will be a smaller piece and this will be a bigger piece. So whenever you cut a circumference, you will get 2 different pieces, one small, one big. But suppose, what if your mother cuts the cake into 2 equal parts? Then there is no minor or major arc. Now consider the P and the Q. Where are they lying? Your center is here. Then if you connect all the 3 of them, you will see that you will get the diameter. And what do the diameters do? They split the circle into 2 equal parts. So there is no minor or major. This is one part. This part will be equal to the other part. In that case, we will not use the terms minor or major. Instead, we will use the term a semicircle. Now, what is a chord? Let us go to that. Chord is a line segment which joins 2 points on a circumference. So you see what is happening here? Your chord is actually a line segment. It is not a piece of the circumference. No, it is actually a line segment which lies completely inside the circle with both its endpoints on the circle. You see the word line segment here. What does that mean? We don't call it a line. A line means it does not have any endpoints. Line segment means it has 2 endpoints, both of them which lie on the circle, and we name the chord PQ. So this means it is a chord and this means it is what? It is an arc. Now the third and the last term that we are going to learn today is a segment. What is the segment? It is the area between a chord and either of its arcs. What is a chord? I have drawn it here. This is your chord. I have drawn it in green. So this line here is your chord. What does it do? It separates your circle into 2 arcs. Here you can see one is minor and the other is major. So it has separated it into 2 different arcs. What is an arc? It is just a piece of a circle. Here it has separated it into 2 different pieces. Then what about the area between this chord and this arc? What about this area here? That is called your segment. Again, there are 2 segments. One segment trapped between this chord and the minor arc. Another segment, this trapped between what? The same chord. But this time it is the other arc, the bigger arc. So you have 3 different terms. What is it? The first one is a simple line which is a chord. The second one is a piece of the circumference, which is the arc. And the third thing is actually an area. Can you see that? It is getting bigger and bigger and bigger. The third one is a segment. What is the segment? It is the area between the chord and its arcs. So one is what? A minor segment. This one, what is the other one? A major segment. So shall we go on to our theorems? Now we come to a very interesting and a very important theorem. What is it about? It is about the arc. Here I have taken a very small arc, a minor arc. We have to consider all the three conditions. We have to consider a minor arc, a major arc, and a third condition where it is neither major or minor, or in other words, it is a semicircle. We will consider all the three cases, but first we will start with a minor arc. And what does your rule say? The angle subtended by the arc at the center. How will that angle look like? It will be formed at the center with PO and OQ as its arms. At the center with OP and OQ as its two arms. Now you have this angle. Now consider another angle subtended by the same arc, but this time on any other point on the circumference. Remember, on the circumference, not inside the circle, not outside the circle, but on the circumference. Consider that angle also. How will that angle look like? It will be formed at the point A with the arms PA and PQ, this angle. Now what does your rule say? The angle at the center is double the angle at any other point. That means if this is 100, this has to be 50. That is your rule. Now I have taken one point. You can take any number of points as long as they lie on the circumference, not inside or outside the circle, on the circumference. And remember, they should all lie in this side. Don't come here. Don't come to this area. This is your arc, and the angle that it makes goes here. Do not come to this area. Now consider any number of points here. All of them will follow the same rule. What rule is that? There. Here you have one angle made at the center, and all of these angles made where? Points, made at points on the circumference. Then all of them are same. These are the angles made at these points. All of them are same. All of them will be 50, 50, 50, and all of them will be half of the angle made here. The angle at the center will be the greatest. All the others will be half. And this is how they all look like. There a 50, again a 50, again a 50 here. See, you can get as many angles that you want. All of them will be 50, all of them will be half the angle at the center. Very interesting, isn't it? Now we come to the second case. In the last case, what did we take? We took a very small, a minor arc PQ. But what have we done here? Here we have taken a semicircle. It is cutting the circle into two equal parts. Then what is the angle made at the center? It will be POQ. There. This is your angle. And what is that angle? You can just look at it and say that it is 180. Now take any point on any, here or here, both will be same. Why? Because it is cutting it into two equal parts. Take anywhere. Let me just randomly take one point here and one point here. What about the angles made at this point? What about the angles that this arc makes at this point? How will it look? It will look like this. It will be made at A, and its arms will be what? PA and AQ. Similarly, this also will follow. But then what will be PAQ? It will be what? 2 times PAQ will be POQ. The angle made at the center is always greater. If this is 180, this one will be half of it, or in other words, what? It will be a 90 degrees. That is the theorem that we learn. Whenever you have a semicircle, the angle that it makes is a right angle. Now the same rule will follow here also. This point also, here it will be same. How will the angle look? It will be formed at the point B. And what will be the arms of the angle? One arm will be PB. The other one will be QB, and this is your angle. The angle is made here again. What do you see? If this one is 180, half of it is 90. So that is your theorem. Whenever you see a semicircle, the angle that it makes, this arc makes, or this line makes anywhere, it will be 90 degrees. Now we come to the last one, which deals with the major arc. Now we come to the third and the final case. What do we deal with here? We deal with a major arc. First was a minor arc, then was a semicircle. Now you have a major arc, but then don't worry, the theorem still holds. Take the angle made at the center. How will it look? It will look like this, but please remember, the angle that it makes is this one. No, don't look inside it. It is the one which comes here. This is the angle that it makes, and at the center. And take another angle which it makes at any point on the circumference. Take PAQ, then the rule still holds. This is double of this angle. Suppose this angle is say 60, then this angle here will be 120. Please remember, do not take the angle in here. It is this angle you have to consider. Both of your angles must look at the same direction. They should not be looking at each other. We don't want it. They should not be looking at each other. They should be looking at the same direction. In each and every case, you will see that. Even if you take a even if you take a minor arc, what do you see? You will see that both of them will look in the same direction. Now it will look like we have learnt three different theorems, but when you come to think of it, the concept is very simple. What is the concept? If you have an arc, then the angle that this arc subtends at the center will be double the angle that it subtends at any other point. Before we go on to our question answer session, let us see a very interesting, a very important term, cyclic quadrilateral. What is a quadrilateral? It is any polygon which has 4 sides. Very simple, right? But then if the vertices of the quadrilateral, what are the vertices here? A and B and C and D. If the vertices of a quadrilateral lie on the circle, then we call it a cyclic quadrilateral. Remember, it has to lie on the circle, not inside the circle, not outside the circle, but specifically on the circle. Then we call it a cyclic quadrilateral, and it follows a very, very interesting rule. The sum of the opposite sides should be 180. That means what? Angle A plus angle C should be 180. Angle D plus angle B should be 180. Or in other words, suppose this is 70, then this has to be 110. And suppose this is 30, then this has to be 150. The opposite sides added should give you 180. But please remember, this is true only when what? All the 4 of them lie on the circle. Now let's go on to our question answers. What do you see here at the first question? You see 2 angles made at the same side of the segment, and both of them are made by AB. And what are their names? Here, both of them are made by AB. One is what? ACB, and the other is what? ADB. And what do you know about them? Whichever point, as long as it is on the same side of the segment, don't come to this place. As long as it is on the same side, they will all be equal, and they will be what? They will be half of the angle made at the center. So it is not asked. If it is asked what is the angle made at the center, it will be double of this, which is what? 140. Now look at the next question. You have a cyclic quadrilateral. What do you know about them? The opposite angles should add up to 180. So if this is 60, this would be 120, and if this is 70, this should be what? It should be 110. They should add up to 180. Now look at the third question. What do you see here? You have one angle which is 100. You have to find what is this angle and what is this angle. Now what is this angle is very simple. Look at this. Both of them made at the same side of the segment. So therefore take half of 100, which is what? 50 degrees. Done. Now look at the angle BPQ. What is the problem with it? These two angles fall in the same segment. So all you had to do is take half of it. But this one falls completely in the other segment. So what do? This is also half of the angle made at the center. But which angle? Not this angle, not the one which faces it. This one is what you have to take. If this is 100, the whole one is 360. If this is 100, this one will be what? It will be 260. Your BPQ is actually half of POQ, but then remember, don't take this POQ. It is the one which forms on the other side. It is this one. Half of 260, which is 130. It is 130. And did you notice one more interesting thing here? Look at PAQB. What do you see? All of them 4 points lying on the circle, which means what? A plus B, the two angles should give you 180. Do they give you 180? See, 50 and 130. That is another way, a easier way to find the answer. But then what will you do if this angle is not given? So you have to learn this method anyways. Let me give you one more question that will make it clear. Now look at this question. What do you see? You see an arc PQ. It is making all sorts of angles. It is making an angle with the center, and one angle it is making in the same side as the center, and one on the opposite side. What are all of these angles? Look at the one which is in the same side. Then what do you have about, what can you say about the angle at the center? It will be double of this, which means it will be 120. But then what about this one? This one will also be double the angle made at the center, but not this angle. This one. Take 360 and subtract this, then what do you get? You will get what? You will get 240, and half of 240 will come here, which is what? 120. And how do you check if your answer is correct? Look at this. YPXQ, a cyclic quadrilateral, and add these two. Do you get 180? You do. So your answer is correct. So this is what we started with. So now you have an idea what is happening here. Here you have a small arc PQ. What happens in that case? All of the angles will be made in the same side. Here is your center. The angle made at the center will be double of the angle made at any other point on the circumference. And remember, all of them stay here. And what is the second case you see? It is a semicircle. No major arc, minor arc, no such drama. So this will be 180. Half of this, again, x and 2x. That is all we are always dealing with. 90, double of it is 180. Now we come to the last case. What was it? It was a major arc. Look at this part here. Nobody should even come to this part. This is your arc now. Do not even come here. All the points will be made on that side. But then there is a small problem here. Because it is the major arc, what will happen? The O, your center, will also be contained in this part. But the rule still remains the same. The angle formed at the center will be 2 times the angle formed at any other point. Remember only here. Don't come into the arc area. This is your major arc. Do not consider this. Similarly, your minor arc is this. All of them will be formed at the other side. Now you have seen the definitions. Now let us see some question answers, but that is in another class. Till then, Assalamu alaikum.